general relativity, in which the architecture of space-time, instead of being flat and linear, is dynamic and curved. This gave the first plausible explanation of the origin of the universe, that the universe began with a cataclysmic explosion called the Big Bang, which sent the stars and galaxies hurtling outward in space. With the pioneering work of George Gamow and his colleagues on the Big Bang theory, and Fred Hoyle on the origin of the elements, a scaffolding was emerging, giving the broad outlines of the evolution of the universe. A third revolution is now underway. It is only about 5 years old. It has been ushered in by a battery of new high-tech instruments such as space satellites, lasers, gravity wave detectors, X-ray telescopes, and high-speed supercomputers. We now have the most authoritative data yet on the nature of the universe, including its age, its composition, and perhaps even its future and eventual death. Astronomers now realize that the universe is expanding in a runaway mode, accelerating without limit, becoming colder and colder with time. If this continues, we face the prospect of the Big Freeze, when the universe is plunged into darkness and cold, and all intelligent life dies out. This audiobook is about this third great revolution. It differs from my earlier books on physics, Beyond Einstein, and Hyperspace, which helped to introduce to the public the new concepts of higher dimensions and superstring theory. In Parallel Worlds, instead of focusing on space-time, I concentrate on the revolutionary developments in cosmology unfolding within the last several years, based on new evidence from the world's laboratories and the outermost reaches of space, and new breakthroughs in theoretical physics. It is my intention that it can be heard and grasped without any previous introduction to physics or cosmology. In Part 1 of the audiobook, I focus on the study of the universe, summarizing the advances made in the early stages of cosmology, culminating in the theory called inflation, which gives us the most advanced formulation to date of the Big Bang theory. In Part 2, I focus specifically on the emerging theory of the multiverse, a world made up of multiple universes, of which ours is but one, and discuss the possibility of wormholes, space and time warps, and how higher dimensions might connect them. Superstring theory and M-theory have given us the first major step beyond Einstein's original theory. They give further evidence that our universe may be but one of many. Finally, in Part 3, I discuss the Big Freeze and what scientists now see as the end of our universe. I also give a serious, though speculative, discussion of how an advanced civilization in the distant future might use the laws of physics to leave our universe trillions of years from now and enter another, more hospitable universe to begin the process of rebirth, or to go back in time when the universe was warmer. With the flood of new data we are receiving today, with new tools such as space satellites which can scan the heavens, with new gravity wave detectors, and with new city-size atom smashers nearing completion, physicists feel that we are entering what may be the golden age of cosmology. It is, in short, a great time to be a physicist and a voyager on this quest to understand our origins and the fate of the universe.